In this video, we will be going over the ellipse. We can define an ellipse in this way, as the set of all points in the plane, the sum of whose distances from two fixed points is a constant. The fixed points are called the foci, which is plural of focus, for the ellipse. Now what's happening here is we have two foci, or focal points, F1 and F2. And then we have a point P. Now what this definition is saying is that the distance between F1 and P plus the distance of F2 and P, if we add those together, we get some distance D. So there's the second distance. Now let's pick a second point. This point, the distance between this point, let's call it P2, the distance between this point and each of the foci, the sum of those distances is also equal to D. So F1, P2, the distance there plus the distance, F2, P2. If I add those distances together, that is also equal to D. I could do this again. Let's pick a point over here. Let's call that P3. The distance, let's draw a straight line. The distance between F1 and P3 and F2 and P3, that is also going to equal the distance D. So F1, P3 plus F2, P3, those distances are also, the sum is also going to equal D. Moving over to the second image, we see that the ellipse is oriented within the XY coordinate plane, and this one has a horizontal orientation. What we could see here is that we have each of our focal points. This distance straight across, this is called the major axis. This short distance across is called the minor axis. These points V1 and V2 are called vertices, so each of which is a vertex. Okay, and then we also have C value for center. So these are the main characteristics of an ellipse that we are going to want to be able to identify. The first type of ellipse we'll discuss is a horizontal ellipse. So a horizontal ellipse has a major axis that is horizontal. So we'll have a center here at HK. And we have two focal points. Let's call them F1 and F2. And then we'll have two vertices. Let's call those V1, V2. So the standard form of an ellipse that has a horizontal orientation is going to be x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. So hk just corresponds to the center. The distance from vertex 1 to vertex 2 is 2a. This is also called the major axis, so 2a is the major axis. That tells us that the distance in between the center and each vertex is a. And then the distance between the center and each focal point is c. So that distance is c, and that distance is c. And then lastly, the distance, what color should I use? Kind of running out of colors. Lastly, the distance from the center to these short edges has a distance of b, and 2 times b is the length of the minor axis. Now what we want to be able to do is identify the center, the vertices, and the focal points, or foci. Now the center we know is h comma k. Now the vertices, well, the distance between the center and each vertex is a value of a. So what we do is we start at the center, hk, and I'm going to move to the left a value of a, and I'm going to move to the right a value of a. So I'm either going to add or subtract a to the x-coordinate. So this will be h plus or minus a, comma k. That gets us the two ordered pairs that correspond to the vertices. Then the focal points, similarly, I'm going to move c units away from the center. So I'm going to say h plus or minus c, comma k. Now, we know where a and b comes from. Those show up in the standard form of the equation, but the c value, we need to solve this equation. C squared equals a squared minus b squared. So that's how we can calculate that c value. One last thing to mention about the equation of an ellipse. So we have a squared here and b squared. We know that a is always going to be larger than b. Okay, so a is the distance from the center to each vertex. B is the distance from the center to, I don't know, like the minor vertex or that short distance to the edge. So a is always bigger, so when we have the bigger denominator under the x term, that's when we have a horizontal ellipse. A vertical ellipse is going to be reversed. The larger value, the larger denominator, which is a, is going to be under the y term. So let's check out the vertical ellipse. All right, so my vertical ellipse looks something like this. We still have a center of hk. We have two focal points. Let's call those f1 and f2. And then I have two vertices, v1, let's say down here, v2 over here. So the standard form of this equation is x minus h quantity squared, but now I have the smaller denominator under the x term and the larger denominator under the y term, still equal to 1. Let me make a better 2 here. Alright, so similarly as when we had a horizontal ellipse, the distance from each vertex is a distance of 2 times a. So the halfway point is going to be a and a there. The b value is the distance along this minor, or the 2b value is here. And then lastly, the distance from the center to each focal point will be c. So identifying the center, the vertices, and the foci. Well, the center is still h comma k. For the vertices now, what I'm going to do is I'm going to start at the center, but now I'm going to move along the y-coordinate a value of a. So this will be h comma k plus or minus a. And then for the focal points, I'm going to add and subtract the c value to the y-coordinate. So h comma k plus or minus c. So just like before, the a value is always going to be larger than the b value. 2a is equal to the major axis, and 2b is equal to the distance of the minor axis. And then to figure out the c value, we're going to say c squared is equal to a squared minus b squared. So this might seem like a lot, the kind of remembering how the vertices and the foci work, but really, if we can remember what a and c represent, all we need to do is start at the center, and we're going to move along, in this case, the major axis, which is the y-coordinate. We're just changing the value on the y-coordinate. When we have a horizontal ellipse, all we're doing is we're changing the value on the x-coordinate. So you don't need to memorize all this if you can kind of work through it intuitively. And that first example says to find the center, the foci, and the vertices of the ellipse, also graph the ellipse. So we have our equation. Now this equation is not in standard form, so what we need to do is we're going to divide every term by 36 because we want the right hand side of this equation to equal 1. So if I divide everything by 36, we get 12 divided by 36 is 1/3, so this is going to be x plus 1 squared divided by 3 plus 4 divided by 36 is 1/9, so this will be y minus 2 squared divided by 9 is equal to 1. Now that we're in standard form, we can go ahead and find the center, the vertices, and the foci. And before we do that, it's a good idea to identify the A value, the B value, and the C value. Now, when we're looking at each of these denominators, whichever denominator is greater is equal to A squared. So 9 is equal to A squared. So A squared is equal to 9. That tells us that A is equal to 3. 3 is equal to B squared. So B squared here is equal to 3. B must be the square root of 3. And then to find the C value, we solve C squared is equal to A squared minus B squared. We already know A squared, that's 9. B squared is 3, so C squared is equal to 6, giving us a C value of square root of 6. So these values are vital for us in order to answer, or in order to find the center, the vertices, the foci, and then come up with the graph. So the center, if we look at our general, or the standard equation here, the center is going to be the h and the k value, so this will be -1, 2. I'm going to go ahead and graph that point right here. The vertices, remember, what we do is we start at the center and we count off whatever the A value is. Now, this ellipse has a vertical orientation, and we know it's vertical because A squared is under the y term. So looking at this term right here, A squared, we know that 9 is A squared because A squared is always larger than B squared, so we know that 9 is A squared. And because A squared is within the same fraction as the y term, that tells us, the y tells us that this has a vertical orientation. So because this has a vertical orientation, from the center point, I'm going to count off 3 units in the vertical direction. So I get that point right there, and then down 3, I get this point right here. So those are the vertices. So those points are -1, 5, and -1, -1. All right, and then to find the foci, what we do is we start at the center and we count off the C value. And again, I'm going to count in the vertical direction. So the y value is what's going to be changing. And square root of 6, that's about 2.5 roughly. We don't have to be 100% precise, but this is about 2.5-ish. So what I need to do is from this center point, I'm going to count up about 2.5, and then I'm going to count down 2.5. So what are those points? Well, the x-coordinate is -1, and then I'm starting at 2 and I'm adding square root of 6. That gets us the focal point that's above the x-axis, and then I'm going to say -1, 2 minus square root of 6. All right, and then the last thing we need to do is label or mark in the minor axis. And again, I'm going to approximate square root of 3. Square root of 3 is about 1.7. So I'm going to go to the right about 1.7 and then the left 1.7. So those are the endpoints of the minor axis. And then I just try my best to create a nice smooth curve. And there we have it. Now a little trick for approximating some of these square roots. Well, we know square root of 1 is equal to 1, square root of 2 is equal, hold on, I want to do perfect squares. Square root of 4 is equal to 2, square root of 9 is equal to 3. Well, for the C value down here, I got square root of 6. Well, square root of 6 is just in between square root of 4 and square root of 9. So I know square root of 6 must be between square root of 2, or I'm sorry, between 2 and 3. That's how I came up with about 2.5. And then square root of 3, well, that's between square root of 1 and square root of 4. So that means it must be between 1 and 2. And this square root of 3 is closer to square root of 4, so I know it's not exactly in between. It's going to be closer to 2 than it is to 1. Alright, next example says to find the center, foci, and vertices of the ellipse, also graph the equation. And then looking at this equation, this looks nothing like what we want this to be for standard form. So what we need to do is complete the square, and I'll begin by grouping the x terms together. So 9x squared plus 72x. I'm going to leave a space, and then I'm going to group the y terms together. So we have plus 4y squared minus 24y, leave a space. And then this 144 I'm going to bring to the right hand side, so that's minus 144. Alright, so looking at the x's, I'll first factor out the 9 because I just want a coefficient of 1 on the x squared. So x squared plus 8x, and then to complete the square I take half of 8, which is 4, and then I square that. So plus 16. Let me write that in a different color. And then for the y's, I'm going to factor out a 4. I'm left with y squared minus 6y, and then half of negative 6 is negative 3. 3 squared is 9, so plus 9 here. And then that's going to equal negative 144. Now be careful, I didn't just add 16 and 9. What I really did was I added 9 times 16, which is 144. So I need to add 144 to the right hand side, and I need to add 4 times 9, which is 36. So plus 36. Now that I've completed the square, I'm going to go ahead and factor this. This will be 9 times x plus 4, so x plus 4 squared, plus 4 times y minus 3 times y minus 3, so y minus 3 squared. And then the one on the right hand side, the 144s are going to cancel, so I'm just left with 36. And then the last step I need to take to get this into standard form is to divide everything by 36, because we want this to be equal to 1 on the right hand side. So I get x plus 4 squared divided by 4, 9 over 36, plus y minus 3 squared, 4 over 36, I get 1/9. So now we have the equation in standard form. And looking at this, whichever denominator is larger, that tells us what the a squared value is. So 9 is a squared, 4 is b squared. And because a squared is under the y term, we again have a vertical orientation here. So let's see if I can cram all of this in. We need to know what the center is. The center is just hk, so that's going to be negative 4, 3. The vertices we need to find, and the foci. We're going to say c squared is equal to a squared minus b squared. So c squared here is going to be 9 minus 4. So c squared is 5, which tells us c has a square root of 5 as its value. So that's c. A is going to be square root of 9 here, so a is equal to 3, and b is the square root of 4, so b is equal to 2. So those are my a, b, and c values. Alright, so let's plot the center. The center is going to be negative 4, positive 3, right here. The vertex, because we have a vertical orientation, the vertices are going to be along the major axis A, and I'm going to move up and down the A value. So the A value is 3, 1, 2, 3, and down 1, 2, 3. So those points, I have negative 4, comma, what is that, 6, and negative 4, comma, 0. And then for the foci, what I'm going to do is I'm going to start at the center, and I'm going to add and subtract the c value, and I'm doing this to the y coordinate. So this will be negative 4, comma, 3 plus square root 5, or negative 4, comma, 3 minus square root 5. So those are the focal points. Square root 5 is a little bit more than 2, so I'm going to move up a little more than 2 and down a little more than 2. And then the b value is 2, so what I'm going to do is I'm going to move to the right 2 units and to the left 2 units from that center point in order to find the endpoints for the minor axis. So I can draw a nice smooth curve in between these, and I get that. So there is the ellipse. And then these next two examples kind of go about things in the opposite direction. Now we're given some conditions and we want to come up with the equation. So we have focal points of 0, comma, plus or minus 3, and then we have a vertex of 0, 6. So this is just saying we have 0, 3 and 0, comma, negative 3 for the focal points. So what I'm going to do is I'm going to go ahead and graph these. Now graphing the foci, we have 0, 3 and 0, negative 3. So like here, let's call that F1 and then F2. So F1 is here, F2 is that point. Now because those are the focal points, we know that the center is directly in between those. So the center has to be 0, 0. So the center is 0, 0, and that tells us what the h value is and what the k value is in our ellipse. Also, the focal points and the center, those always line up along the major axis. So because the major axis is vertical, that tells us we have a vertical orientation, and the standard form, or the equation, is going to be of the form x minus h squared over b squared plus y minus k squared over a squared is equal to 1. So we've already figured out what the h and the k values are. Now let's take into account what this vertex is. The vertex is 0, 6. So that means this point up here, 0, 6, that's one of our vertices. Now the other vertex, well, this distance is 6. That means the distance from the center to the other vertex is also 6. So the other vertex must be 0, negative 6. And because that distance is 6, that tells us that the a value is equal to 6. And the distance from the center to the foci, which is 3, that tells us what the c value is. So c is going to be 3 here. Now we can use these two values to figure out the b value. So remember, c squared is equal to a squared minus b squared. C squared is going to be 9. A squared is 36 minus b squared. So we're going to get negative b squared is equal to negative 27. Let's make those both positive by dividing by negative 1. So we get a b value of 3 square root 3. But in the equation, we don't really care what b is, we really care what b squared is, so we can just drop in a 27 there. So writing this all together, we have a center of 0, 0. Because this is going to be 0 and this is going to be 0, I'm just going to write x squared and y squared. So x squared over b squared, which is 27, plus y squared over the a value squared, and the a value is 6, so a squared is 36, and that is going to be equal to 1. And we have our equation. And then the last example is similar to the last one. We have a center of 3, 1, a focus of 5, 1, and a b value of 2. Graphing these pieces, the center is at 3, 1. So there's the center. We have a focal point at 5, 1. Let's call that F. And then the center is there. And then the b value is 2. Well, looking at the center and the focus, this looks like we have a horizontal orientation because the focus and the center are always lined up. And what we notice is that the distance between the center and the focus is 2. That means we're going to go to the left 2 units to get to our other focal point. So F2 here. And also that tells us that the c value is going to have a value of 2. Alright, so once we know b and c, we can find the a value. C squared is equal to a squared minus b squared, so c squared is 4, equal to a squared minus b squared, so 2 squared is also 4. Okay, a squared is equal to 8, so a is going to be, when I take the square root of 8, that's 2 square root 2. So that's the a value. However, in the equation, we really just need to know what the a squared value is. So we know that this has a horizontal orientation. Because this is horizontal, this is going to be of the form x minus h squared over a squared plus y minus k squared over b squared. That's going to equal 1. So again, because this is a horizontal orientation, the a squared value is under the x term. Okay, so we know the center point, that's 3, 1. So that's going to be x minus 3 squared plus y minus 1 squared. It's equal to 1. And then the a squared value is 8, so that goes in the denominator in the x term. And then the b squared value, well, b is 2, so b squared is equal to 4. And so there's our equation. But let's go ahead and actually finish graphing this. So the b value is 2, so that tells us we're going to go down 2 units from the center to get the endpoints on the minor axis. And then the a value is 2 square root of 2. So 2 times square root of 2, well, square root of 2 is about 1.4. So if I multiply that, that's about 2.8. So what I'm going to do is I'm going to go about 2.8 in each direction from the center. And then I can come up with the ellipse. So the vertices here, what I'm going to do is I'm going to start at the center, 3, 1, but I'm going to add that a value to the x-coordinate. So this will be 3 plus or minus 2 square root 2, 1. So I'm going to add 2 root 2 to get to the focus to the right, and then I'm going to subtract 2 root 2 to get the focus in the left.